Bismillahirrahmanirrahim. This is Pakistan International School Taif. Can speak grade 11. Yesterday we completed the only how the X-rays are going to be discovered, discovery of X-rays. So when the X-ray was discovered accidentally by Wilhelm Röntgen in 1895, then atomic number was discovered in 1913. In 1913, the atomic number was discovered by using this same experiment. Now, atomic number was discovered by Moseley in 1913. Now, how he discovered? He used same instrument, same process. He studied systematic, comprehensive study of the X-rays in 1913, and Moseley done the experiment according to his experiment, and he recorded the wavelength, that is why 0.04 to 0.08 angstrom. His researches covered the range of wavelengths 0.04 to 0.08 angstrom. Then he proved that Moseley proved that the frequencies of X-rays, I told you when the X-ray was discovered, the frequencies of the X-rays increases in the regular manner from one element to other in periodic table. In the X-ray discovery written here, that the frequencies of the X-ray directly proportional to the atomic number of protons, and same he observed. Again I am telling you that according to Moseley, frequencies of X-rays increase in regular manner from one element to other in the periodic table. Then he further suggested that the frequencies of these rays are directly proportional to the number of protons in the nucleus. So number of protons in the nucleus means atomic number. If we have a carbon, so number of protons are 6. So atomic number is also 6. Protons are 6. Atomic number is 6. For the fluorine, number of protons are 9. So atomic number is 9. So according to this X-ray experiment and his comprehensive study, he proved that frequencies of X-rays directly proportional to the number of protons, and these number of protons means atomic number. He further suggested that frequency I told you earlier. Then moreover, Moseley drew following conclusions. These are the conclusions drawn by the Moseley. And he performed the experiment, and he used 38 different elements. 38 different elements he used in the X-ray, from aluminum to gold. 38 elements from aluminum to gold. So he observed that frequencies are directly proportional to the number of protons from aluminum to gold. Then there are some points here. Conclusions. Number 1, spectral lines could be classified into two distinct groups. Spectral lines. Spectral lines are classified into two distinct groups. One with long, shorter wavelength called K series. Shorter wavelength called K series. Shorter wavelength is called K series, and larger wavelength is called L series. Larger wavelength is called L series. So this is a point number 1. Second point is, if the target element is a higher atomic number, suppose this is a gold, higher atomic number, highest one, the wavelength of X-ray becomes shorter, and this is given for the discovery of X-ray, that wavelength is inversely proportional to the frequencies of X-rays. Wavelength is inversely proportional to the X-rays about this one. This is given here. Written here, the wavelength of X-rays produced depend upon nature of metal target. You can see in the discovery of X-ray, and same point is used by the Moseley in 1913. If the target element is a higher atomic number, the wavelength of X-ray becomes shorter. Same point. It means that he studied very highly concentrated and many repetitions, and we can say systematic and comprehensive study on the X-ray by the Moseley in 1913. Point number C. The relationship between the frequency and atomic number. I told you this is a directly proportional. Frequencies and atomic number is, this is the under root, this is the frequency is equal to A Z minus B. This is called a Moseley's law. This is the Moseley's law. Where A and B, this A and B are called Moseley's constant. Where this A and B are called Moseley's constant, Z is atomic number under root frequency. So the law states that frequency of spectral line in X-ray spectrum varies square of the atomic number of element emitting it. So in 1913, when the atomic number was discovered, then arrangement of the element in the periodic table was also changed. Before this arrangement of element was by the Mendeleev's scientists, Mendeleev's chemists, Russian chemists, according to their atomic masses. Before this modern periodic table. The periodic table was arranged according to atomic masses, increasing atomic masses. Now the periodic law is changed after the discovery of atomic number by using X-ray. So according to the modern periodic law which was given by Moseley in 1913, that physical and chemical properties of elements are changed in the periodic function of their atomic number. Now if you look the periodic table, so it is arranged according to atomic numbers: hydrogen 1, helium 2, lithium 3, like this one, beryllium 4, boron 5, like this one. So this is according to increasing their atomic numbers. So this is a modern periodic law. This is now again he explained the X-rays atomic number and orbital structure. This mostly this repetition points already we discussed, but now I am going to explain you. Actually, Moseley was the student of Rutherford. In 1913, Henry J. Moseley, student of Rutherford, used technique X-ray spectroscopy. Already I told you, X-ray were discovered accidentally, so he used these techniques comprehensively. Just discovered by Max von Loo to determine the atomic numbers of elements, I told you. X-ray produced in cathode rays tube when the electrons beam cathode rays fall on the metal. Same experiment done for the discovery of electron by the Crookes, Faraday and J.J. Thomson's experiment. The explanation for the production of X-ray is as follows, same as I told you. When electron in the cathode rays hits the metal target, and he changed the metal target periodically from aluminum to gold, about 38 elements. So the frequencies and wavelength of the X-ray are going to be changed, already I told you. So when the electron in the cathode rays hits a metal atom in the target, it can, if different energy, knock out an electron from an inner shell of an atom. This produces a metal ion with an electron missing from an inner orbital. So that's why the electronic configuration is unstable, and electron from orbital higher energy drops to the half-filled orbital, and photon is emitted in this process. The photon corresponds to electromagnetic radiation in the X-ray region. So this is the phenomenon of the X-ray atomic number and orbital structure by Henry J. Moseley in 1913, student of Rutherford. Now students, you heard the name of X-ray because it is used in the radiology department to take the X-ray of internal parts of the body. Big use. I am going to explain this uses of X-ray. Particular applications are followed closely heels of discovery of X-ray, because X-ray have a different penetrating powers for different types of matter. They can be used to photograph inner parts of object. Already I told this used to observe the broken part of the body. So Roentgen original announcement of X-ray was December 1895. On January 20th, 1896, another scientist that's called Dartmouth New Hampshire X-ray were used to assess the setting of broken arm. This was something of the record time of turning of scientific discovery in the practical application of the X-rays. Nowadays you can see X-ray of broken part of the arm, leg, or internal body of the human being can be watched by the doctors, radiologists. This is number one application. This is very important. Second use is crystals. Students, you know the solids. Solids are two types. One is called amorphous solid and other is called crystalline solid. So these crystalline solids have a proper arrangement of the atom, ions, particles inside. Fixed shape. So this proper arrangement of the particles in crystals can be analyzed, explained according to X-ray. This is given here. The layers of closely packed particles in the crystals constitute planes. So in 1912, Max von Loo is a German scientist. He suggested particles and the planes of the wavelength. So because of this technique is called crystallography. X-ray diffraction technique. X-ray diffraction technique to observe the internal arrangement of particles of the crystalline solids. So I am reading again this one. So this Max von Loo is a German scientist, suggests that particles and the planes of crystals might be separated by distances that are of the same order of magnitude as the wavelength of the X-rays. Therefore, a beam of X-ray should be diffracted by the crystal. That's why the name is called X-ray diffraction technique. The suggestion was quickly verified experimentally, and a highly symmetrical diffraction pattern that appears on the photographic film is known as Loo pattern of substance, according to the name of that scientist. Now, in England, 1913, William Bragg and Lawrence Bragg, two scientists, maybe brother. William Bragg and Lawrence Bragg devised a simple apparatus to determine the internal structure of the crystal, which already I told you, and this technique is called X-ray diffraction techniques. So dear students, there are two main uses of the X-ray are given here in your book. Number one is to observe the internal parts of the body, fracture part of the arm, leg, then doctor can analyze, then it is going to be treated. Number two, that internal part of the crystal. These two applications are very important in our daily life. So students, this topic is going to be over. Now, very important, very important topic, other topic I am going to start. Quantum numbers and orbitals. orbitals. Now, according to the Bohr's theory, electrons are revolving in a circular path, circular way, are called orbits. Orbits, energy levels, shells. These paths, circular paths, are called energy levels. These are called orbits. These are called shells. But this is called orbitals, so we will discuss here. So the name of scientist already I told you, Schrödinger. This I told you in the uncertainty principle when we discussed this. Schrödinger in 1926, he derived an equation is called wave equation, mathematical derivation for the wave equation, in which electrons are treated as moving with a wave-like motion in a three-dimensional space around the nucleus. Already I told you in the previous when I told you uncertainty principle that this electron treated maybe the particle nature and maybe the wave nature, that's why we call dual nature, but the Schrödinger equation name is a wave equation. That's why he treated electron as a wave-like motion in the three-dimensional. But in the different atomic model, Bohr's atomic model, already I told you, electrons move in orbits, I told you, circular orbits. Different. It also specifies the distance between the electron and the nucleus. If you see the book, but if it's not present, you must remember. Consequences of quantum mechanical treatment of atoms are as follows. You have to remember, if not present in your book, then you have to remember, you have to write also these words. Number one, the energy of electrons in atom is quantized, quantum, I told, discontinuous. Packets in the form of packets, in the form of bundles, quantum, photon. Electrons with different energies are to be found in different regions. The position and movement of electron can determine at the same time, cannot be measured at the same time. This is called uncertainty principle you done before. Now, I told you the definition of orbit. According to Bohr's atomic model orbit, electron revolves around the nucleus in circular path, circular way is called orbit. But what is orbital? The region or space around the nucleus in which the probability of finding electron is maximum, about 95%, are called atomic orbitals. Again I am repeating, it is given in your book. The region or space around the nucleus in which the probability of finding electron is maximum, in bracket 95%, is called atomic orbital. So these atomic orbitals are S, P, D and F. These are called atomic orbitals. The solution of Schrödinger wave equation gives certain mathematical integers, these sets of numerical value which give the acceptable picture of an atom where the electrons revolve are called quantum numbers. The set of numerical values which give the acceptable picture of an atom where the electron can revolve is called quantum number. So students, there are four quantum numbers. So one by one I am going to explain. So number one is called principal quantum number. Principal quantum number, which is denoted by small m. And this principal quantum number is totally based upon Bohr's atomic model. Principal quantum number is totally based upon Bohr's atomic model, that electrons revolve around the nucleus in circular path. Then, to this circular path, according to this quantum number, it determines the size of orbit and distance from the nucleus. Size of the orbit, you done this radius of orbit calculated, and I told you 0.0529 nanometers. Size of an orbit and distance from the nucleus you can determine by using the principal quantum number. Greater the distance from the nucleus, larger the size of the orbit. Greater the distance from the nucleus, larger the size of the orbits. The shells or orbits are we call energy levels. So students, n, if n is equal to 1, we call K shell. N is equal to 2, we call L shell. N is equal to 3, we call M shell. N is equal to 4, we call N shell, and so on like so. 1, 2, 3, 4, 5, 6 like K, L, M, N. These are the number of shells, and each shell has a fixed number of electrons. You done it in the grade 9. The formula we use 2n square. So if I am going to calculate the number of electrons in the first orbit K shell, so n is equal to 1. So 1 square. So 1 square is a 1 multiplied by 2. It means that in the first K shell, the maximum ability to accommodate electrons are 2. Means you accommodate electron maximum in the K shell 2, not more than 2. You can accommodate 1 up to 2, not 3. Students, if you have a 2, so 2 square, 2 multiplied by 2, 4 multiplied by 2, 8. So up to 8 electrons can be accommodated in L shell. And 3 multiplied by 3, 9 multiplied by 2, 18. So 18 electrons can be accommodated in the M shell. Now 4 are 16 multiplied by 2, 32. So 32 electrons can be accommodated in N shell number 4 according to Bohr's formula 2n square. So you can energy of the electron and space around the nucleus. The formula is 2n square. I have written. So this is the first quantum number we call principal quantum number. Principal quantum number. So students, there are 4 quantum numbers. So inshallah, next lecture I will explain the number 2, that is called azimuthal quantum number. So just I am going to some introduction about this one. It describes the shape of an orbital. Azimuthal quantum number explain or describe the shape of an orbital and also sub-energy levels SPDF. So we are going to conclude here. See the topics very well and prepare for the examination. Thank you very much.